My very strong suggestion is that in these calculation problems, you write the calculator answer down first, then determine the appropriate number of significant figures. As you can see, I've already written down the calculator answer to these problems. We'll spend our time focused on determining the number of sig figs. In this first problem, we see our first number here has 1 decimal place, i.e. it's rounded off to the tenths place. Our second number goes all the way out to 5 decimal places. So in our response, our final numerical answer, we're limited to the tenths place. We cannot go beyond the tenths place. We look at the first number to be dropped. It's greater than 5, so we add 1 to the preceding decimal column. This results in an answer that's essentially unchanged from the initial number. 18.9 minus this very small number is still going to equal 18.9. It is the same as the initial value within significant figures. What this means is that this number is insignificant compared to the size of this number. Subtracting a very tiny value from 18.9 does not change its value within sig figs. In other words, we say that this value, 0.00333, is insignificant compared to 18.9. We will encounter this concept multiple times through the semester. Our second problem is also an addition problem, so we use the rule where we count the decimal places. We're paying attention to the decimal places of these numbers that we're adding together. This has 0 decimal places, which means it's rounded to the ones. This has 2, it's rounded to the hundredths, as well as the third and the fourth number. And our rule is that we can't go beyond our worst decimal place. In this case, our worst decimal place is the ones place, or in other words, we report our answer to 0 decimal places. Our correctly reported answer is 122. In problems involving multiplication and division, we count the number of sig figs in each number leading to our result. You see here we have 3 sig figs. This number has 5 sig figs. We see that there's a trailing 0. However, this number contains a decimal point, so that 0 is significant. Same is true for the denominator, which has 2 sig figs. In this case, our answer is limited to 2 sig figs. The first number we drop is less than 5, so we just drop all of the digits past the 8. Our correctly reported answer is 1.8. In D, we see we have a captive 0. This number has 3 sig figs. This leading 0 in the second number does not count. Leading zeros do not count. However, this captive 0 does. So the second number has 3 sig figs. And since this is multiplication and division, where we are counting the number of sig figs, we're going to report our answer with the same number of sig figs as our worst measurement. The worst measurement has the least number of significant figures. So we look at our result. We can use 3 sig figs in our result, which means we're going to round things to the tenths. We look at the first number to be dropped. We see it's less than 5. We round down. Our correctly reported answer is 86.1. In this last problem, also multiplication division, so we count sig figs. When we look at the numerator, we see that all those zeros are captive. They count, so our numerator contains 5 sig figs. Our denominator has a leading 0, which does not count, and each of the ones counts. So we can use 2 sig figs in our final answer. To express this result with 2 sig figs, first what we're going to do is to convert this to scientific notation. The first step will be to determine the coefficient. The coefficient is always a number up to, but not including, 10. So in order to do that, we see we've moved the decimal point 5 spaces. That means our exponent is going to be a 5. It's going to be a positive 5 because the number that we're converting is greater than 1. Now we round our coefficient to a number with 2 sig figs. The first number to be dropped is less than 5, so we round down. And our final correctly reported answer is 2.7 times 10 to the 5th. Now in this instance, we must absolutely use scientific notation to express the correct number of sig figs. Let's see why. If we attempted to report the answer as 270,000, that would be incorrect because this has an ambiguous number of sig figs. These are trailing zeros and a number without a decimal point. If we tried to write this as 27,000 with a decimal point, this would indicate that there are 6 sig figs. This number, these trailing zeros, are in a number with a decimal point and therefore count as significant. So 6 sig figs, which is an incorrect number of sig figs. Finally, we would not be able to write this as 27 because that is simply the wrong value. If you want to argue with me, why don't you give me $270,000? I'll give you back 27.